So good morning, everybody. This is Peter McGuire coming to you from our studio here in beautiful Medford, Oregon, here representing Lighthouse Worldwide Solutions and Filtr. Today, we're here to talk about the filter revolution for air purification. We want to, first of all, thank you, everybody, for attending. At the end of this, we will have a Q&A session, and you're welcome to send your questions through the webinar. And we'll also list a name and a phone number at the end if you want to call and have a more detailed conversation. So we're really excited about this opportunity. Thank you for the state of Oregon for inviting us. So today we're obviously talking about a very critical topic, and it's really the reopening of schools, office spaces, and buildings, and how we can maintain safety and keep our personnel and our children safe. So let's jump in and we'll get started. One more final point, there will be email sent out or text sent out with a very quick questionnaire at the end to follow up to make sure that you have received the information that you feel is necessary. So first of all, our company started in 1982. And believe it or not, we're headquartered right here in beautiful Southern Oregon, in Medford, Oregon. So we have 12 service centers around the world. Our company has been focused on contamination control for 35 years. That means we work within some of the cleanest environments in the world. And for some companies like Bayer, Baxter, AstraZeneca, Intel, Samsung, Raytheon, and so forth. And we've become experts in contamination control. So here's a few of our customers that I just mentioned to you. So we're talking about, obviously, COVID-19 and the reopening of schools. And this first slide shows us sort of a history of pandemics. What you're seeing here is the larger the virus, unfortunately, the more deaths have occurred, right? So we can see the coronavirus is somewhere just over 2 million deaths and obviously climbing right now. So it's a fairly serious pandemic in our history. Another takeaway from this slide is you can see here that pandemics aren't abnormal, right? We had SARS more recently and MERS and Ebola and so forth, and that's all been in the last 10 to 15 years. And so it seems like every 3 to 5 to 7 years, something new pops up. So this is something really to pay attention to. For those of you out there, just to understand what we call the R0 number, where we're comparing the flu against COVID-19. And the R0 number basically shows how contagious COVID-19 is. And so we can see a normal flu. If you have one person catches the flu, they can spread it out to 1.3 people. With COVID, it's somewhere between 2 to 2.5 people. Incubation time is longer with COVID, which makes it trickier. It means that you can have the virus, you can show up to work, you can feel good, but you're actually still contagious. Hospitalization rates are much higher, and then unfortunately, mortality or fatality rates are much higher. So I want to talk about the transmission vectors for COVID, right? How it transmissions from one person to another. So typically how it spreads is either droplet transmission, airborne transmission, or physical contact. And we're going to go into those in the next couple slides. Something I want to emphasize here is the physical size of the virus itself. So it's somewhere between 0.08 and 0.12 micron, and that's fairly small. To give you a perspective, if you took a cross section of a hair, that's going to be somewhere between 50 and 100 microns in diameter. Under normal light conditions, your eye can see down to about 35 to 45 microns. So you're talking about something that you can't see under normal light conditions, not even close, at 0.08 to 0.12 micron. So transmission vectors for COVID-19, right? We have droplet transmissions, things like sneezes and coughs and so forth. When we speak, we have things coming out of our mouth. The droplet transmission, when we talk about those, tend to be about 5 microns or larger in diameter. And they have a range at which they travel, and we'll show that on the next slide. Airborne transmission are things that are less than 5 microns. And I mentioned earlier, human hair, cross-section of a human hair, somewhere between 50 and 100 microns in diameter. So pretty small. So we can see here from this graphic, when we exhale, right, we have particles that come out of our mouth can go up to about 1.5 meters or roughly 5 feet. When you cough, it goes a little further. It's coming out at about 2 meters or 6.5 feet. And when we sneeze, shockingly enough, sneezes can come out at up to 100 miles an hour, and they can travel up to 8 meters or 24 feet. So that's a pretty far distance for a sneeze. If you're a big sneezer, look out. So that's why we have common sense things like when you sneeze, obviously you should always have a mask on, but when you sneeze, you can sneeze into your arm so that it's not going off into the environment. There's been some recent articles that have come out in the American Association for Advancement of Science talking about PM 2.5 or particle matter 2.5 and mortality rates. And there's been an association where when you see an increase in particle counts, that you actually see a higher rate of mortality with people who got COVID. So this is a very interesting correlation that's happened like in the last 6 months. So again, PM 2.5 stands for particle matter. And I'm sure a lot of you are familiar with PM 2.5 and its size. Again, here's a reference of a human hair at 50 to 70 microns. Beach sand is 90 microns. You have PM10 and then you have PM 2.5. So PM 2.5 is all particles from 2.5 micron all the way down to 0.3 micron. That's what makes up PM 2.5. You'll hear this PM 2.5 a lot in air quality. You hear outdoor air quality or indoor air quality, and they'll measure PM 2.5 particles. Here's another slide referencing size. So on the far right, we have 10 micron, that's PM10. A blood cell is about 7 microns. PM 2.5 is 2.5 microns. Bacteria goes down to roughly 1 micron. The smallest virus known to man is 0.02 microns, where again, COVID is somewhere between 0.08 and 0.12. So let's call COVID-19 is 0.1 microns. So extremely small. Again, nothing that you're going to see with the eye. This next chart shows us if you took a particle in still air and you dropped it, how long it would take to fall 1 meter or 3.2 feet. So we can see on the far right-hand side with a 100 micron particle, it's going to fall 3.2 feet in 1.7 seconds. The extreme other side, if you took a 0.1 micron particle and you drop that in still air, it's going to take about 466 hours to fall just 3.2 feet. So we can see these smaller particles are obviously less affected by gravity and more affected by just molecules. And obviously we don't live in a still air environment. So as soon as you've got fans, your HVAC system, right, you're stirring things up. As people walk, they stir contamination off the floor and loft that back into the air. So these are all things that affect how long particles stay in the environment. And remember, COVID-19 is down at that 0.1 micron level. So if it does come out on itself, by itself, at extremely small sizes at 0.1 micron, it's going to stay in the air for up to 466 hours, and that's on still air. So the spread of COVID is also by physical contact. Two people shaking hands, which we don't seem to do anymore. Little statistic, on your hand, you have 10,000 microorganisms per square inch. So the body is covered in microorganisms. You think about all the surfaces in a day that we come in contact with. You grab a door handle, you're in an escalator, you're touching a phone, you're touching a friend's phone. You put that phone down, what's the surface contamination that now has come onto that phone, your keyboard, a desk, you're pumping gas. So you think about all the surfaces that we come in contact with in a day. Now, how long does COVID last, right? So in air, they've done studies and it will last up to 3 hours. If it lands on a copper surface, up to 4 hours, on cardboard, up to 24 hours, on plastic, 2 to 3 days, and on stainless steel, 2 to 3 days. So that means if you're in an environment and someone sneezes, it gets on a surface, and that's on a Monday. And let's say that surface doesn't get cleaned. By Tuesday, someone comes in, sits at that same desk, picks up that contamination, maybe they itch their eye, and they have a transfer of the virus. And so we have to be very careful about surfaces as well. So here's an example where we touch our face on average of 16 to 20 times per hour. So what's the solution? How do we solve, how do we make it a safe work environment? How do we make it a safe environment for our children that are going to school, our teachers, and so forth? Well, as I mentioned before, we've been in the clean room industry for 35 years. The clean room industry has been fighting contamination, pollutants, everything from viruses, bacteria, mold, inert and inert particles, right, for 40 years, 50 years now. So these are the cleanest environments in the world. And so I'm going to share with you some information about clean rooms and how it's going to relate to opening your environments, to making them safe for your kids and your parents that are working in those environments. So here's very simplicity how a clean room works. You can see from this graphic we have air filtration, where these green lines represent air coming in through a HEPA filter, and we'll talk about a HEPA filter in a second. The air comes down through the room and flushes the room and cycles back around through their HVAC system and back through HEPA filtration. So if you've ever had a chance to be in a clean room, obviously you're gowning and so forth, and we're not going to get into gowning practices today, but really a clean room, you have a controlled environment with walls, you have clean air that's flushing through, and a clean room still has particles, but it's really about flushing those particles out as soon as possible, because once you add people into an environment, we shed particles, we have spittle coming out of our mouths and so forth, right? So we're contamination sources. In fact, in a clean room, we're the #1 source of contamination. Well, clean rooms also work off of positive pressure. That means air is forced into the environment so that when a door opens from that clean environment, air blows out, not dirty air comes in. And I've got a graphic to show you what I mean in a few minutes. So again, on this slide, we're flushing air, we're pushing very clean air, particulate-free air essentially, into the environment to dilute and remove any sources of viral, bacteria, mold contamination that might be airborne. So a lot of you have probably heard the term HEPA. HEPA stands for high efficient particulate air. And you'll see statistics like HEPA filters remove 99.97% of particles at the 0.3 micron range. We call that range the MPPS, most penetrating particle size. So HEPA filtration is really the standard in clean rooms. It is what is utilized in clean rooms 99.99% of the time. It's HEPA filters. There are other filters like OPA filters, but HEPA filters really are the standard within clean rooms because they're so effective at removing small to large particles. Here's how a HEPA filter works. So as you can see here, each one of those black dots is a filter fiber. So imagine this is a cross-section of a filter. And you have particles that come through. So those little awesome red lines that you're looking at now, that's airflow coming through those fibers. You can see a large particle as it comes through. We call this sieving. So let me give you a simple example. You're home, you want to have pasta for dinner, you boil the noodles, you get a colander out, you pour the water and the noodles into the colander, all the water goes through the colander, and you have what left is the noodles. In this particular case, it's because those noodles are larger than the holes in the colander. Well, that's the very same, this is true also for HEPA filtration. As a large particle comes through, it can't fit through the openings or between the fibers, and so it impacts on the surface, and we call that sieving. You have an inertial impaction. Inertial impaction is where a particle is following the airflow, but as the air goes around a fiber, because that particle is large enough and has inertia, it keeps going straight, runs into a fiber and sticks to the fiber. So that's the second method for particle removal of a HEPA filter. You have diffusion. Diffusion method basically is what removes smaller particles from the air, 0.3, 0.2, 0.1, and so on. Diffusion mechanisms based on Brownian motion. So you have molecules bouncing around. Because these particles are so small, they bounce into molecules and they hit a filter fiber and they're physically removed. So that's diffusion mechanism. Finally, the fourth mechanism is electrostatic charge, where you have a negatively charged or positively charged particle that attracts to a negatively or positively charged fiber. So for those of us that are old enough on this call, if we remember CRT TVs or displays, you could wipe down a CRT TV and the next 2 days later, 3 days later, it would have a layer of dust. And that's because there was a surface charge on that CRT TV that was attracting and bonding particles to the surface. So HEPA filters work on interception, electrostatics, inertial impaction, and diffusion. Those are the four mechanisms for how a filter works. Here's the MERV rating system. If you're in the HVAC industry, I'm sure you're familiar with the MERV rating system. It basically shows the higher the MERV number, so we start at MERV 1, we go to MERV 16, the better the filter is at filtering out particles. What's a common filter now, or what's a recommended filter now lately, has been a MERV 13 filter. We can see here a MERV 13 filter at 0.3 to 1 micron is a less than 75% removal efficiency. And then as you go up in particle sizes, 1 to 3 micron, 90%, and again, 3 to 10 micron, 90%. HEPA filter starts at a MERV 17 and goes up to a MERV 20. So when you're targeting specific coronavirus, remember it's 0.1 micron. Now the coronavirus often doesn't come out as just a coronavirus. It comes out on the back of sputum, on the back of something larger. So it'll attach itself to something larger and float around. But still, coronavirus, we have to remember, is roughly 0.1 micron. We talked about clean rooms and positive pressure. So how positive pressure works, if you were to force air into a room, then that's positively pressurized. Then when you open a door to that room, air blows out, not dirty air comes in. So clean rooms operate in this manner. The cleanest environments in a clean room will have the highest pressure, and they'll have something called cascading pressure. Now, I'm not suggesting we go out and we pressurize our rooms, but we do have customers that we have safe rooms, or let's say you've got someone who has an allergy or asthma. They may positively pressurize the bedroom or the office that they work in, so that it keeps it extremely clean, so that, again, open the door, open a window, air blows out, not dirty air blowing in. Here's a particle size, or a relative particle size chart, where we can see different viruses. I mentioned the smallest virus is 0.02 micron and up to just over 0.5 micron. Bacteria ranges in size from about 0.3 micron up to 10 micron. Wood smoke, which is something obviously we face here in Oregon because of fires that we have every year. Wood smoke goes down to roughly 0.2 to 0.3 micron and up to 1 micron. Wood smoke has obviously been a major concern. So a MERV 13 filter, as you can see here, is a less than 75% removal efficiency down to 0.3 micron, which means you're missing a lot of tobacco smoke, smog, atmospheric dust. You're catching a lot of the wood smoke, but not all of it. And then obviously viruses and COVID-19 is at 0.1. The filtration unit that we utilize in our filter, called Revolution, it actually, we've tested it down all the way down to 0.024 micron. And we have a 98% removal efficiency from 0.024 all the way up. So you can see we're pretty much capturing everything that's in the air, which we're producing particle-free air. So choosing the right filter for the right application, again, just emphasizing that our own HEPA filter is 99% and above at 0.3 micron and 98% removal efficiency at 0.024 and all the way up, where a MERV 13 filter is 75% less efficient or less at 0.3 and 1 micron. Here's some specifications on our filter unit. So you can see here that the unit produces 600 CFM. CFM stands for cubic feet per minute, and this is based on with a pre-filter and a HEPA filter. Total system removal efficiency at 0.3 micron is 99.99%. What this means is that when we sell or provide a unit, you actually get a certification where we test the unit. Air comes into the unit, and we look at the air coming out. Almost no other company in the industry does that type of testing. Everybody will state the specification for their filtration, but they don't spec the complete system. Why the complete system is important is because things leak. You can have a great filter, but a poor sealing system, and particles are going to go around the filter and blow out the other side, right? So total system particle removal efficiency is critical. We have bipolar ionization integrated into this unit. This ionization does not make ozone, and I'll go into more detail in a minute about how the ionization works. And another very key topic that I find a lot of people are missing here is that we have to think about decibel level or sound level. We're putting these units into classrooms, we're putting these units into office spaces. People have to be able to work and speak and communicate and hear effectively. And so our unit stops at 60 decibels on high, and I'll show you how that relates to sound here in just a couple minutes. But decibel level is critical. We have a carbon filter that's integrated into this unit. Carbon filter is designed to remove things like volatile organic compounds, chemicals, and so forth. We have a washable pre-filter that you can just take it out, wash it, and put it back in. Onboard sensors. So the unit actually has onboard sensors for temperature, humidity. Yes, PM 2.5 and VOC, which stands for volatile organic compounds. That data is, if you attach the unit to your Wi-Fi, will push data to the cloud, and then on your phone, you can have real-time data as to the environmental conditions in every room in the area that you've installed the Revolution in. It will also send you emails to let you know if an out-of-spec condition occurs. So this unit is not only providing you particle-free air at a sound level that makes sense for the environment, but it's also giving you data to tell you how the room itself is performing, and will alarm if there's an out-of-spec condition. Here's the inner workings of the unit. So the air intake is coming down here next to the wheels. Air comes through that washable pre-filter. There's a carbon filter here that you can choose to use or not use. If you're not concerned of smell, you would take it out. Air is pulled through. We have a high efficiency blower here that pushes the air and pressurizes this cavity. Air then goes through our custom designed HEPA filter, past the bipolar ionization, and then out the top. So here's our central module that I just talked about. It's giving you PM 2.5, temperature, humidity, and VOC data. We also have a protective screen to make sure that if something drops down here into this cavity, one, it's nearly impossible to get through here, but if it was to get through here, also there's a screen that protects this blower. This isn't just a normal standard blower. Lighthouse Worldwide Solutions and Filtr, we're an engineering company. So everything that we've done and put into this is commercial grade hardware. So that blower by itself is rated at 10 years of continuous 24/7 running time. So the HEPA filter, this is from a service and maintenance standpoint. Depending on the environment that you're in, you only need to change that filter every 2 to 5 years. So it's very low maintenance. Carbon filter, because chemicals, depending on the chemical concentration in the air, needs to be changed every 3 to 4 months. Pre-filter just needs to be washed, and there is no service or maintenance required for the bipolar ionization, the sensors that are on board. And again, I mentioned the blower has a 10-year continuous operation life. So again, these are all commercial grade hardware. There is a graphic of the app, right? So again, you get temperature, humidity, you can set your alarm limits, you get your PM 2.5 data, and actually there's another screen that will show you a graph of the data. So you have all of the power and information right in your hands as to each room that you've installed the Revolution in your building or your school. We're going to talk a little bit about bipolar ionization, right? So bipolar ionization works in two ways. One, bipolar ionization puts out positive and negative ions into the environment. These charged ions surround contamination, things like bacteria, viruses, and mold, and break them down. Also, it causes particles to agglomerate. So you can see here on the left, you've got a bunch of individual particles. They're exposed to bipolar ionization, and these particles agglomerate. Why that's important is because once those particles get larger, remember that chart that shows how long it takes to fall 1 meter, right? The heavier or the larger the particle, the faster those particles fall out of the breathing zone. So bipolar ionization is more what we call an active air filtration, where it's going out, those ions are going out into the environment and helping to reduce contamination. Bipolar also works on surfaces. So there are studies that have done over time where surface contamination basically builds up. The bipolar ionizations will start to break down that surface contamination. So here's a study that was used with a novavirus where we put this in a chamber, and in 30 minutes, we had a 93.5% reduction in that virus. You can see human coronavirus, Legionella disease, and so forth. 60 minutes, we had a 99% reduction. So not only are we filtering those viruses and bacteria and so forth out of the environment, but the bipolar ionization helps to sanitize surfaces in that same environment. So you get two benefits. Bipolar ionization also reduces VOC, volatile organic compounds. So those are smells, things like coming off plastic surfaces and so forth, off of paint. If you have new carpet, that carpet smell is VOC. You bought a new car, that new car smell, which we all so much love, is actually not healthy for us. That's VOC. So bipolar ionization has many benefits. Our design for bipolar does not make ozone, and we've been certified by UL for that. So now I want to talk about sound levels. And for those of us, I'm going to date myself maybe a little bit. Remember the story about the three bears, right? And this bed was too soft, this bed was too hard, and this bed was just right. So when we talk about sound levels, we have to figure out what's right for your environment. And it was funny, I was just shopping the other day, and I happened to run into a school teacher, and they had bought some filtration units. And I said, oh, how's it working out for you? It wasn't ours, it was another brand, no problem. I'm always here to help and consult. And she mentioned, well, these units are filtering air, they're HEPA filters, but they're really loud. And we have to turn them down so that during class we can hear. Well, in my mind, turning down a filter, that's a red flag, because it means you're not getting the same level of filtration that you should be getting to keep your students, to keep your teachers, to keep your coworkers healthy. So we're going to talk about sound levels and find out what's just right for you. So a little bit of background on decibel levels. So as a rough number, every increase in 6 decibels, you have a 50% increase in sound level. So if you think, oh, well, this unit's just 60 decibels, this one's 65 decibels, oh, what's 5 decibels? It's small. Well, 5 or 6 decibels is a 50% increase in sound. And if you were to take a single air purifier, a single room, and add multiple air purifiers, so for every additional air purifier you add to your room, your first one, you can see here in this graphic, the first one, let's say, is 50 decibels on medium speed. You add a second unit into the same space, you add 6, you don't add 50 plus 50, it's 50 plus 6, so you're at 56 decibels, but remember, that 6 decibels just made you 50% louder. And if you add a third unit, you would add roughly 3 decibels, and that 3 decibels is going to put you at close to 100% louder than that first unit. So when you're evaluating against sound, you need to pay attention to how loud something is, how many decibels is it rated at, and then how many units you're going to need to clean your environment effectively. So here's a chart that shows leaves rustling is about 10 decibels. A whisper is about 25 decibels. A quiet office is about 40 decibels. Normal conversation, like I'm having now, is roughly 60 decibels, and a vacuum cleaner is 70 decibels. So really what our target here, what we're suggesting is you want to stay to about 60 decibels or lower. And that way you're able to leave the unit hopefully on high if it's designed properly, so that you're not interfering with a teacher, you're not interfering with basic conversation. So you can see here, what you're looking at here is something called CFD studies. CFD stands for Computational Fluid Dynamics. So what we're looking at is we have very sophisticated software programs and high-powered computers, and we're designing our unit and fine-tuning the fans and the design, the structure, the shape, to reduce things like air currents and eddies and blockages, right? The more we can reduce those, the more efficient the unit is, the more air it puts out, and guess what? That's right, the quieter the unit is. And so we've designed our unit to be quiet, but be very effective at delivering a lot of CFM, cubic feet per minute, of particle-free air. So here we can see, I just randomly picked a few instruments on the market that I've seen in environments before. You've got this, that all of these 4 units, and obviously our unit has a HEPA filter. We can see the flow ratings here and the decibel ratings. What I'm going to tell you is really anything under 200 CFM, unless you're just in a private small office, I wouldn't even spend my time on it. So I would say that's not important. Get rid of anything that's less than 200 CFM. Then at 200 CFM, we take a look at decibel levels. So this particular unit is 63 decibels at 250 CFM. Remember what we said, 60 decibels is really the highest that we want to go. This unit has 250 CFM at 66 decibels. This unit, 240 CFM at 58 decibels. And this unit, our unit, is 400 CFM at 56 decibels. So remember, again, that above 60, it's too loud. You should see, I actually was just, I'll tell you a little side story. I was just traveling. I was in Wichita, Kansas, doing some consulting work for other companies that are looking to open. I went to the Wichita airport, and they actually had this blue unit in the airport, blowing air across the floor, which actually is not a good idea. You don't want air blowing across the floor. Why? This is a test question for you, even though I didn't give you the answer yet. Right, foodborne contamination. 15% of contaminants that get lofted into the air come from foodborne contamination. You think about, you walked outside, you might have actually stepped in dog poo, you're in the restroom, who knows? You're bringing things into the room that you don't want to breathe into your mouth, you don't want to touch. So if you buy a filtration unit, don't blow air across the floor. You should always suck from the bottom and blow out the top. And then decibel levels. So in the airport, which is a pretty wide open space, they had this unit set on low. I turned it up to high, and I understood completely why. At 73 decibels, you could not talk within 20 feet of that unit. So you really have to pay attention to decibel levels and CFM. So we're going to talk a little bit about installation details. It's a common question that comes up. How many units do I need for my classroom, for my office space, for my home? And I'm going to break that down for you, right? So step 1, we have different mounting options. This unit comes with wheels, and so you can roll it into an environment. Again, the air comes down, pulls through here, and blows out the top. Ceiling mount, which we really like, and I'll show you why, because it performs better. And we also have a wall mount unit, right? So all 3 mounting options are available for you. We did some CFD studies, again, computational fluid dynamics, to look at which direction was optimum for cleaning a space. So we took a 6,000 cubic foot room, so roughly 750 square feet, or 6,000 cubic feet, and we mounted the revolution in a horizontal, or in a vertical, in a horizontal manner. And then we compared the cleanup times of how fast particles were removed from the environment. All of these little lines you can see here, these are traces of particles and the movement of particles in the environment. So when we put the unit in the center of a room, we blew air up hits the ceiling, and comes back around. It took 128 minutes to fully clean up that room where there was 0 particles. We did that same test where we mounted the unit from the ceiling, and we blew air, hits the wall, and comes back through. So it took only 25 minutes. So you can see in a vertical orientation, 128 minutes. In a horizontal orientation, only 25 minutes to clean up. So when possible, we suggest trying to mount these from the ceiling. You take a simple piece of unistrut and a cable, and you can mount it from the ceiling. Here's how we positively pressure the environment. So you can see here room A and room B. As air gets pulled into the unit and pushed in, just like you would in a clean room where you're positively pressurizing the environment, now room A is positively pressurized. If I was to open a door or a window, the clean air would go out of the room, not dirty air coming in. So that's a simple example of how clean rooms can do it, how you can do it at home or in an office space. Coverage area is a very common question. So we're going to walk through 3 easy steps to figure out how many units you need to cover your area. So step 1, we want to calculate the cubic volume of air in your room, right? So to calculate cubic volume of air, you take length times width times height. So let's say in this particular case, I have a ceiling height of 10 feet. I have a room that's 20 feet long by 30 feet wide. So 20 times 30 times 10 gives me 6,000 cubic feet of air. So far, so good? All right, that's step 1. Step 2, we have to decide how many air changes we want in that room. So in recent meetings, I've heard numbers like 5. And I know the EPA has come out and said in ASHRAE, if you're familiar with ASHRAE, has come out and said they're recommending 5 air changes per hour. So step 1, we calculated the 6,000 cubic feet of air. Step 2, we're going to look at the number of air changes per hour. So if the number of air changes is 5, well, then we take 6,000 times 5 equals 30,000 cubic feet. So we know in the course of 1 hour, we want 5 air changes. We know the room is 6,000 cubic feet. So in 1 hour, 6,000 times 5, we have 30,000 cubic feet. Well, now we can figure out the air purifier or the number of air purifiers based on its CFM. Remember, CFM stands for cubic feet per minute. So now we have the 30,000 cubic feet. Step 3 is we calculate in 60 minutes, I take 30,000, I divide it by the time, which is 60, and I have figured out that I need 500 CFM, cubic feet of minute, of clean air for 5 air changes per hour. Pretty simple, step 1, step 2, step 3. So we can see here in our room where we want 30,000 cubic feet or 5 air changes per hour, our unit, you only need 1 unit. It's going to be running at 60 decibels at 600 CFM, and actually you get more than 5 air changes per hour in that room, or you could put that in a larger room and still get 5 air changes per hour. On one of the previous units we covered, it's going to put out 240 CFM, so really you're going to need 3 of those units to get all 5 air changes in an hour. Those units run at 58 dBs, but that's 58 dBs for one. We're going to add 6 for the next one. So now you're at 64, and we're going to add 3 more for the next one. So you're at 69 decibels, which is not practical for a room because you wouldn't be able to talk. And then this particular unit, you're going to have to, you would run it at 125 CFM. That's going to be 55 decibels, and you're going to see it's going to keep adding up from there, which is also not, you're not going to be able to talk. So again, decibel level is critical. Otherwise, what's going to happen is you're going to spend money on a unit. You're going to go from high, you're going to turn to medium so that you can talk, and you're not getting the same airflow on medium that you would on high. Here's a case study that we actually did right here in Portland. So this was a case study where we took one of our Revolution units, we put it in a classroom. This was just recently on February 1st. The classroom dimensions were 23 by 39 by 11. So it had 9,867 cubic feet of air. Classroom was empty at the time. In this particular case, in the course of an hour, that was 3.64 air changes. So if you wanted 5 full air changes, you would need 2 units in the space. We took a particle counter because our company makes particle counters. A particle counter is something that counts dust or particles in the air at different particle sizes. You can see here from the graphic, this isn't the whole room. This is about half the room that you're looking at here, but it was roughly 10,000 cubic feet. We can see our Revolution air purifier here on the right. The particle counter is over here on the far left. And then what we do is we put this in a room. We turn off the air purifier. We take background measurements on the particle counter for 10 minutes. Then we turn the unit on, we leave the room, and we watch how fast the room cleans down. Really, this is the optimal way to test a room to know how effective the filtration unit is. So we can see here's our background level. So the background counts were ranging about 1.2 all the way up to about 1.35 million particles per cubic foot. That's what you're breathing. At 0.2 micron, we turn the filter unit on, the Revolution on. You can see an immediate drop within just a couple minutes. At the end of 60 minutes, we had an 82% reduction in 0.2 micron particles. When we go to 0.3 micron particles, you can see here per cubic foot, that ranged roughly about 250 to 275,000 particles per cubic foot. We turn the unit on, again, an immediate reduction, and then a slow reduction continually over time. We had an 82% reduction in 0.3, in 0.7, 1, and 2 microns. We had an overall 92% reduction in particles. Now, a lot of people will say that these larger particles are what COVID rides upon. So these larger particles is really what we're targeting right now to remove as quick as possible. Remember, we can remove those through air filtration, which is the HEPA filter that we've designed. You can also remove them through bipolar, because those positive and negative ions, they make those particles attract, they get larger, and they fall from the breathing space. Now remember, when they fall and hit the ground, that's another reason why you don't want to have air blowing across your surface, because all of those things just get lofted back into the environment again. So we can see here a summary. Overall, we had an 84% particle removal across all of our particle sizes. So summarizing, so this unit puts out 600 CFM, 600 cubic feet of air per minute. It has bipolar ionization. It's removing particles way below the 0.3 micron range at 98% removal efficiency all the way down at 0.024 micron. We have onboard sensors that are recording temperature, humidity, PM2.5, and VOC. So they're pumping data up to the cloud. You get data on your phone. Another review, so HEPA filters only need to be changed every 2 to 5 years. Carbon filtration every 3 to 4 months. You can wash the pre-filter depends on period of time, how dirty the environment is. You have no service on the bipolar, no service on the sensors, and the blower is rated at 10 years of continuous operation. So really, we're saying this is one of the best additions to your HVAC system. You can actually look at your HVAC system and say, well, that's handling the 5 air changes, and we're going to put in this Revolution unit, and it's really going to keep the environment safe and clean for my kids, my teachers, my coworkers. We talked about 80% reduction in 1 hour. There's no HVAC upgrade required in this particular case. So you could put a unit in, instead of upgrading your MERV rating on your HVAC system to a MERV 13, you could just put this unit in the room and save on yearly maintenance costs or reduced filter changes. And I'm going to go back to that one slide. I'm going to cover just a couple more things. So what you have to understand about upgrading your filtration system is that when you move from a MERV 8 to a MERV, let's say, 13 filter, you have additional pressure drop that's going to happen. It means that system has to work harder to push the same amount of air. For older systems, I mean, actually some schools don't have an HVAC system, they have mini splits, but for the older systems, oftentimes they can't keep up. So you put in an additional restriction, the unit's going to put out less air, which means your unit has to work harder, you're going to have a higher energy cost, and it actually can damage the overall system. So when you're adding a separate system, a standalone system like Revolution, it's not taxing on your system. And in fact, For your existing filters in your HVAC system, it's going to elongate them. Means because we're cleaning the air that they're pulling in, it means those filters are going to last longer. So you can push out your maintenance cycles between those filters and save on money. So now we're going to open it up for Q&A time. It looks like we're right on schedule with 15 minutes left. So our trusty operations person is going to put up the questions that have come in so far today. So it looks like the first question on the list is, what are the practical use scenarios for the product? Well, it's really any environment that you want to maintain in a clean manner. So absolutely, it's office spaces, it's classrooms, it's if you're working from home, your bedrooms, warehouses. And what you need to remember is that you just need to size accordingly. So we went through that simple step 1, step 2, step 3 to look at the length times width times height, so we know the cubic volume of air in the room. We need to know the number of air changes that we want, and then we can divide by 60 and figure out what is my CFM, cubic feet per minute. Then I can look at the number of the air purifiers and say, oh, this one puts out 400 CFM, this one puts out 600 CFM, and I can calculate how many of those I might need. So really it's appropriate for any type of office, any type of environment. We have these in doctors' offices. We actually have them in surgery environments, in hospitals. We have them in schools. We have them in office buildings. And so just depends on any environment. The price range we'll cover here in a minute, but the state of Oregon has negotiated some extremely beneficial pricing for the state. So you can thank all your purchasing power in the state of Oregon. But I do have a slide here that we can put that up and cover that. As far as how big of an area it covers, it's again, we're 600 cubic feet, so you have to look at the volume of air in the space and do those calculations. One thing I didn't cover, I missed that slide, is when you're evaluating an air purifier, because there's no governing body in air purification, there's lots of little shenanigans that happen. You'll see a company and they'll say, oh, our fan speed is 400 CFM. Well, that's the speed of the fan without a filter. So if you want to buy a unit and turn it on and take out the filters, which makes no sense, the fan speed might be 400 CFM. So you have to really pay attention when you're reading a data sheet or a technical file on an air purifier, is look very closely. They use little tricky words like fan speed or decibel levels. They'll give you a decibel level at the lowest flow rate, which doesn't really mean anything, because what I mentioned is really 200 CFM and above is what you should be thinking at a bare minimum. Otherwise, you've got so many units in your room that you're wasting electricity. You're becoming additively louder from a decibel level. So I have the next question here is, how do you define the number of air changes required? Well, the ASHRAE, which is the organization that governs heating, ventilation, air conditioning systems, they've come out and published a paper that said 5 air changes. You also have the EPA, that they've also come out with a document that they're recommending 5 air changes per hour. So, and that's a number that I've heard actually in the state of Oregon through the school district, if they've come out and recommended 5. Obviously, for larger environments, maybe harder to do 5. It just depends on the environment. If you need help calculating or need help understanding, well, I've got an irregular shaped room, what do I do? Please reach out and call us. We're free consultation. Again, we've been in the cleaning industry for myself for 24 years. I've been in thousands of clean rooms across the globe, and I can share that knowledge and experience with you. We're really here to help protect you, to help protect your children, and so forth. And again, we're right here in the state of Oregon. We're right here in Medford, Oregon. Another question just came in. If you're cleaning the air before it goes through the HVAC, how can it only require filter changes every 2 to 5 years when HVAC has more filter surface area needed and changed once every 1 to 4 times per year? So the surface area that we have inside our filter is almost 100 square feet. A common filter, let's say a MERV 8 or a MERV 13 filter, A standard filter is only going to be 3 to 10 feet of surface area. So it's a much lower surface area. Now, filters, and most people don't understand this, filters over time get better with age. Why? When you think about the removal of how things are removed in a filter, you've got sieving. Remember, large particles going through those fibers can't fit. Well, as particles build up inside those fibers, right, it's harder and harder to get particles through. So filters actually gain efficiency. A HEPA filter gains efficiency with time. I know companies in the semiconductor world that haven't changed HEPA filters in 20 years. However, the reason you would change a filter is because of pressure drop. As particles impact onto the surface, again, filters clog, and it becomes harder to push air through that filter. Here it says, well, we change filters every 1 to 4 times a year. My question back to you would be, is that based on pressure drop, or is that just a standard maintenance cycle? And obviously your pre-filters are changed more frequently. For the pre-filter in our unit, we suggest that you wash it. Probably good to clean it every 3, maximum 6 months to remove the big debris from the unit. But the HEPA filter itself is going to run, depending on the cleanliness of the environment, somewhere between 2 and 5 years. The next question just came in. Keep them coming, guys. This is awesome. We've got 9 minutes and 23 seconds left. So what's the maintenance cost, including the new filters and frequency and recertification? So there is no recertification required for the unit. When you buy a replacement filter from us, it comes already certified. So we'll test everything before we ship it, as does the whole unit. Remember I said earlier that when you buy a filter unit from us, we're not just telling you, oh, this is a HEPA filter. We're testing to make sure the filter doesn't leak, and we're giving you a certificate to that fact. In the pricing agreement, which is number 0596 for the state of Oregon, we've negotiated pricing for the base unit and the replacement filters. If I recall correctly, I know the HEPA filter replacement, which is again every 2 to 5 years, is somewhere in the neighborhood of about $250 to $275. So that's just going off of memory, but that is in the document from the state of Oregon. See, are there any other questions that are coming in right now? Awesome. I think there should have been one more slide in my presentation if you want to go back to the presentation, and I'll pull up the pricing. The pricing here in Oregon, list price is $3,300 for these units. These are commercial grade units. If you buy 1 to 49 units, price is $2,295. 50 to 199 units, $2,095. 200 to 299 units, $1,895. And 300 to 500 units is $1,695. So there's also pricing in that sheet, the Oregon price agreement, again, 0596. Which also gives you replacement accessory cost. Any other questions coming in? Oh, we got one more question, so don't go away. Hold on for 1 second. Again, I want to emphasize that if you have any questions, you can reach out to me. Again, my name is Peter McGuire. Phone number is 541-863-9464, 541-863-9464. Please give me a call. I literally work 7 days a week, and you're welcome to reach out to me anytime. A lot of this can be new for people, and they have a lot of questions. We'll be happy to come talk with you, possibly even come meet with you, depending on schedule and distance. But we're really here to support you, to make a difference, to keep our students, our parents, our teachers safe. All right, so it looks like I have a statement here. All the filters are $284.27 to give you a point of reference. So $284.74. Can you please repeat energy usage? We can cover. That's going to be on our data sheet. If I recall correctly, on high, I think we're under 2 amps. And it's a standard 110 or 120 outlet. But energy usage, give me a call and we'll be good. How long is the pricing good for from the state of Oregon? If we don't change, I believe if we don't change them for 5 years, price Much higher. Got you. I have to go back and review the contract. I don't remember how long the contract is good for. It's definitely easily a year, but we're not going to be price gouging. We're going to be holding our pricing, but I'll have to get back to you on how long that's good for. Oh, I just got a flash across my screen. Pricing for the state of Oregon is good through the end of this year, and then we'll obviously continue that from there on. More questions look like they're coming in. They're pouring in by the second. I love it. So if you'd like a copy of the presentation, please reach out to us via email, or you can give me a call. Again, Peter M. at golighthouse.com. PETERM at golighthouse.com. There you go. And my phone number is 541-863-9464. Please, no problem to call, no problem to email. We really are here to help. We can help you pick the number of locations. We can help you sort of design a system. We were just in touch with a large school. They've got 500 rooms. And we were just talking about, well, where do you place these rooms? Where do you place the filtration units? Where's optimum? And so forth. And so we can help you with all of that. Okay, no more questions? Going once, going twice. Everybody, thank you very much for listening. Oh, we got one more question at the very last minute. Here it comes, folks. One more minute. I also want to emphasize that these are actually manufactured here in Oregon. And so services here, they're manufactured here. We are an Oregon-based company, and we are proud of it. What's the standard length of power cord? Standard power cord comes with 6 feet. It's a pigtail, so it's easy to change, sort of like if you remember a standard computer cord. So you can just plug in a longer cord if you need something longer, but it does come with a 6-foot cord, and that's easy to change. So for example, if you're mounting it to the ceiling, you have power out to the wall, then you could just make it a 10-foot or 12-foot cord and plug it in. Okay, we've got 2 minutes and 35 seconds. Last round of questions. Okay, going once, going twice. It's been a great round of questions. Really appreciate it. So again, just to remind you, there will be a survey that's sent out. It's very helpful for us if you can respond to that survey. Let us know if this information was helpful. We're looking at holding other webinars to share with you other technology, to go even deeper down the rabbit hole of air filtration. So, but again, thank you very much for participating. We want to keep our students and our parents and our teachers safe. Please give us a call. Let us know if you have any questions. Go out and have a fantastic day today. Thank you for your participation. Bye-bye.